morning, afternoon, evening, forever you're watching. Welcome back once again to the Mickey Masters, a channel solely dedicated to demystifying mathematics, making complex problems look easy. Today, I'm going to examine top 9 mistakes that students make that cost them precious marks in the examination. So come along, stay tuned to the end, and let's see, so you will not avoid those mistakes. Now, mistake number 1, let's look at this question. You have negative 4 to the power of 2. Now, because you know that you've been told that the exponent, if the exponent or the power is even, then our answer should be positive. So we say negative 4 square is equals to 16. Now, pay attention, this is not correct. Why is it not correct? Because this negative here is not part of the base. The base here is 4. It's not part of the base. Negative 4 squared means, what it means is that negative 1 times 4 to the power of 2. Now, 4 to the power of 2 is 16. 4 times 4, 16. So that's negative 1 times 16, which will give us negative 16. So negative 4 squared is negative 16, not 16. The only way it would have been 16 if it was in bracket. If it is something like this, negative 4 to the power of 2. And this one means negative 4 times negative 4. Negative will cancel negative. That will give us 16. So don't make this first mistake. When you have a question like this, the negative is not part of the base. It's a separate entity on itself, in itself. So those are two different things. Negative 4 square is negative 16. All right, let's look at mistake number 2. We have looked at mistake number 1. Let's look at mistake number 2. Now, look at this question here. This is 8 minus 4x minus 5. Now, one of the mistakes students make, we'll do this, is 8 minus 4x minus 20. That will give us negative 4x. This is minus 12, or say negative 12 minus 4x, anyone. Now, this thing you are seeing here is not correct. Why is it not correct? Because there's a subtle mistake we have made in this. Let me show you the mistake. This is 8 minus 4 into bracket x minus 5. Now, in this place, what we distributed here was 4, not negative 4. It is negative 4 we are supposed to use to expand the bracket. Now, this is 8 minus negative 4 times x, negative 4x. Negative 4 times negative 5, that will give us positive 20. So look at the mistake here. Here is like we are distributing the 4, not negative 4. So this becomes 8 plus 20, that's 28, minus 4x. So don't make this second mistake. So this is the correct answer, not this. And here you can factorize it out, or we can say 4 into bracket negative 4 into bracket x, then minus, this is 7. You can put that as your final answer, as the case may be. So don't make that mistake. When you have this, when there's a negative here, use it to expand the bracket. This negative, when you're multiplying everything in the bracket, take note of the sign. Don't ignore it and multiply. So don't make this mistake number 2. All right, let's look at mistake number 3. If you have a question like this, 2 over 3 plus 1 over 2, this is a fraction we are adding in. Now, some students, we add like this, since it's addition. I will add the numerator and the denominator together. So I will say 2 plus 1 over 3 plus 2. 2 plus 1, I have 3 over 5. No, this is disaster in mathematics. You don't add. If the denominators are different, we do not add the denominators. What do we need to do? We need to get a common denominator before we can add the fraction. And how do we do that? We find the LCM of the denominators. And the LCM of 3 and 2 is 6. Now, 3 in 6 is 2. I will now say 2 times the numerator here, multiply it, that's 2, plus 2 in 6. How many 2 will I see there? 3. So I'll say 3 times the numerator here, 1. That becomes 2 times 2 is 4, plus 3 times 1 is 3 over 6. This becomes 4 plus 3 is 7 over 6. Now, don't leave your answer as an improper fraction. Put it as a mixed number. Don't make that mistake again. Most times, marks will be deducted if you leave your answer as an improper fraction, because you have not finished simplifying it. So we'll put our answer as a mixed number. So this becomes one whole number. How many 6 will I say in 7? 1. Remaining 1 over 6. So avoid this third mistake. All right, let's look at mistake number 4. X squared equals to 16. Now, some students will do like this. Will x squared, take the square root of both sides, which is good. Now, square will cancel square root, and you say x is equals to 4. This is a partial truth. This is not the complete solution to it. Now, what is the complete solution? Remember that square root means what will I multiply twice to give me this number here? It's not only 4 that I can multiply that will give me 16. There is another complete solution. There is another number. How do we get it? This is x squared equals to 16. Now take the square root of both sides, just like we did. This will become this. Now, the square root of 16 is both positive and negative 4. So it is not only positive 4, so don't make that mistake. Now, here our x is negative 4, or our x is 4, because negative 4 times negative 4 will give us 16. I hope you have learned not to make this mistake anymore. All right, let's look at mistake number 5. Don't fall into this trap. Now look at this. This is very common. You have 3x plus 9. The first thing, some students will do it like this, plus 9 over 3. So you say 3 here, 1, 3 here, 1, 3. This 3 will cancel this 3, and we are left with x plus 9. That's what I call beautiful nonsense. No, this is not correct. What mistake did you make? This 3 is not for only one of the term. It is for the two of them. So this is the same thing as saying 3x over 3 plus 9 over 3, because this 3 is for both of the terms because of this addition you have there. Now, so this 3 will cancel this 3, so I left it x plus 3 here 1, 3 here 3, x plus 3, which is the right answer. Or you can solve it like this by factorizing the numerator. How do we do that? 3x plus 9 over 3 is equal to, when I factorize the numerator, what is common between these two? 3 is a common term, so I bring out 3 into bracket. 3x in 3 is x plus 9 divided by 3, 3. So this is x plus 3 over 3. So 3 will cancel 3 in this scenario now. So you have x plus 3, which is the same thing as this. Don't make that mistake. All right, let's look at this next mistake, mistake number 6. Now you have a question: 5 times 3 to the power of x equals to 225. Now, the first thing some students will do, the mistake, you say 5 times 3, that's 15 to the power of x equals to 225. Now, I'll say 15 raised to the power of what will give me 225. That's 15 to the power of 2 will give me 225. Therefore, it follows that x is equals to 2. Wrong. Now, you can't multiply the base of a constant. It's not possible. Now, how do we resolve this? Very easy. This is 5 times 3 to the power of x equals to 225. The first thing we do is to remove the 5 from there. Divide both sides by 5. So we divide by 5. Divide by 5. 5 here 1, 5 here 1. Because this dot is multiplication. So to remove multiplication, we introduce division, the inverse. So this becomes 3 to the power of x equals to 5 here 1, 5 here 45. 45. Now 3 to the power of x is 45. How do we resolve it? If you don't have a calculator, you can do this is x. Use your log. It will be equals to log 45 base 3. You can finish it up with your calculator to get your answer, but this is the answer. Our x is log 45 base 3. All right, let's look at mistake number 7. Look at this. When you have something like this, x to the power of 4 times x to the power of 3, some students might do it like this, x to the power of 4 times 3, which will give us x to the power of 4 times 3 is 12. No, this is not correct. Now, when you have the same base from the laws of logarithm indices, you are meant to add the bases. This should have been x to the power of 4 plus 3, which is equals to x to the power of 7. How do we get that? Or why is this one correct? Look at x to the power of 4 means x times x times x times x. 4x. X to the power of 3 means x times x times x. Now, how many x did we see here? 1, 2, 3, 4, 5, 6, 7. X to the power of 7. So this is a little way of proving it, showing to you that this is correct. Now, in the same vein, if I have something like this, x to the power of 4 divided by x to the power of 3. Now, some students might do it like this, x to the power of 4 over 3. That will give us x to the power of 1.75 or thereabout. Now, this is not correct also. What you should do when you have x to the power of 4 divided by 3, divided by x to the power of 3, you are supposed to subtract the powers, the exponent. So this is x to the power of 4 minus 3, which is x to the power of 1, which is the same thing as x. Now, how do we get that? We will use the same thing to prove. X to the power of 4 is x times x times x times x over divided by x to the power of 3 is x times x times x. Now this will cancel, this will cancel, this will cancel. We are left with 1x, which is equals to x. So don't fall into that trap. All right, let's look at mistake number 8. Now, when you have something like this, sine open bracket a plus b. Some students might do it like this, sine a plus b is equals to sine a. You split it plus sine b. This is not correct. Or when you have a logarithmic function, you have log x plus 5. You now say log x plus log 5. No, this is not correct. Now, this sign is a function. These things are function. You cannot split them like this. Sine a plus b, when you expand it, you are supposed to get sine a cos b plus sine b cos a. This is how the expansion of this sine a plus b will give us. This is what you should have, not sine a plus sine b. No. And this one, we leave out this like that. We'll leave it out like that. So take note, this is a function. You can't expand it like this. You can't distribute it over what is in the brackets there. All right, lastly, let's look at the last mistake students make that has caused them precious mark. Now, this is x plus 2 to the power of 2. Some students will simplify it like this, x to the power of 2 plus 2 to the power of 2, which is equals to x to the power of 2 plus 4. No, this is not correct. What you are supposed to do, since there's an addition there, you can't just put the powers there to each term. No, you have to expand this bracket. And how do we expand it? This is x plus 2 multiplied by x plus 2. That's what this thing means. Squared means multiply it by itself. Now, this becomes, so we use the FOIL method. The first term to the first term, x times x, x to the power of 2, x times 2. That's the outer. X times 2, that's 2x. Then the inner terms, we multiply the inner terms, 2 times x, 2x. Then the last terms, x times 2 times 2, that's 4. So this is x to the power of 2 plus 4x plus 4. So this is the expansion of x plus 2 to the power of 2. I hope you have enjoyed today's class. So I also hope you have learned something and you will not make that mistake in your subsequent examinations anymore. If you enjoyed the class, why not give us a like, give us a share, tell your friends about the Making Maths Class, a channel solely dedicated to demystifying mathematics, making complex problems look easy. If you are yet to subscribe, please kindly hit the subscribe button, turn on the notification bell so you don't miss out on wonderful content on the channel. If you need a personalized tutor for mathematics, you can reach out to me and I will attend to you. Till meet again in the next Making Maths Class. Keep practicing. Remember, mathematics is fun. See you at the top. Shalom.